Welcome back, everyone. Our final lecture of the day is by Professor Jessica Huelgas Moreno, a lecturer at UNAM and consultant in AI and digital transformation. Beyond her teaching and research, she has been driving force in promoting responsible and accessible AI across different sectors. Her talk is titled Doctors versus Algorithms: How Medicine and AI Understand Disease Differently. This promises to be a fascinating and thought-provoking discussion that challenges how we see both medicine and technology. Please welcome Professor Jessica Huelgas Moreno.
Thank you very much, Fanny. Well, this talk is about doctors versus algorithms and how medicine and AI understand disease differently. And the other talks that we have heard, we realize that doctors cannot measure the way artificial intelligence with neural networks does. So this is a very big challenge for us because while physicians doesn't speak these languages like mathematics, probability, statistics, the way artificial intelligence does, we have a huge challenge as society, as professionals, because imagine two doctors, moreover, to make these professionals and then study all of this, it could be very, very difficult. So they maybe won't make it. So that's why we are here, because we want to bridge the gaps and to help us each other, because there is a global necessity for us that they can use, physicians can use this type of tools. So how are we going to make for them in order to understand faster and to use these tools faster? So this is a challenge that we are going to invite you as young professionals to make for the future. So let's start with framing the contrast between doctors and artificial intelligence. So, for example, if we are going to ask some doctors, when you think of disease, what comes to mind? Well, doctors, how do they understand disease? Well, they make it less alive, and they are also contextual, because as the other talk said, it depends on the regions, for example. It depends of the economical situation. So it is not the same, even the backgrounds for each region. Also, imagine when you are suffering a pain, sometimes you don't know how to describe to the doctor your pain. The only thing that you want is to kill the pain. But imagine the doctor that you are going to describe, it hurts, it's itchy. Sometimes you as a patient doesn't know how to describe your own pain. Sometimes you doesn't know how to describe your own organs because you don't have where are they. So this is a very challenging profession for doctors and benevolent topic. So they also understand disease because they have a lot of experience, some of them, and some of them has a lot of work to do in the path. But now we are going to ask to the AI robot, when you think of disease, what comes to mind? So as we saw before with Dr. Thomas DeSerno and Dr. Tim, the artificial intelligence algorithms think in terms of statistics, data, probability, and here I said structure and structured data, but it is a lot of work to do. And how do they both can we manage in order to get to the same results, or even one helps the other? So we need to start analyzing again the epistemological differences. What is epistemological differences? Well, is how the knowledge is built. For example, doctors, if we think of them in the clinical reasoning, some of them has hypotheses or case-based reasoning, like differential diagnosis, and rely on tactic knowledge. Some of them are heuristic, and of course they embody experience because they can touch us. They have the intuition, and some of them hide the patient history. But look at this, also depends on the regions. How many times you go to the doctor and then go to another doctor and both say different things, right? So as an example, some of the doctors, when see you that you are paler, they can tell what you have before tests to confirm it, right? But now ask again to the algorithms, and they are pattern recognition at a scale. Is something that a doctor can't. They are correlation or not necessary causation. As we talked before, it is a black box decision making, like deep learning, and versus interpretable models. For example, I am going to show you how, for example, artificial intelligence detecting diabetes retinopathy from images more accurate than average ophthalmologists without understanding the biology. So a computer doesn't care what is biology, but even then, he can't predict some of the disease. In this case, we can see a healthy eye, and then we can see some of the diabetic eye. But this is a very hard work to do, because which one of these yellow patterns, maybe if they are in another region, how the doctor or how AI is going to know that it is diabetic or isn't it? So this is a very full task where physicians and scientific persons needs to bridge the gap in order to communicate each other. And we also realize, for example, that when scientific, like computer scientists or engineers, speak with doctors, with physicians, for us it's very difficult to understand. And even it's for them. If they want to talk with us or to understand some things, also for them it's very difficult to understand our languages, even if we speak the same Spanish or the same English. So it is a huge challenge for both, because both we have a tool, we would like to use it, but we don't have the skills to make this work. So what is the time required for a physician to examine one medical image in relation to the thousands of images that an AI system can analyze in a matter of seconds? And this is because we show computers how to analyze pixels, and they are faster than a human being. So of course there is a type in the world of fear, because we can say that artificial intelligence algorithms are going to kill some of the professions. So that's why people is very scared about that. And also, it is because all of the mathematics that since they were a child, maybe scared the people. That's why sometimes they use not to study something related with pure mathematics. For example, if we got in deep with ontology of disease, do you know what counts a disease? Who is the organizations that establish what is a disease and what is not a disease. Let's bring this in mind. For example, is aging a disease or is a natural process? Because right now, the mind are changing. And now, if you read some literature, they are saying that it's not a natural process. That if you make some things by yourself, you are going not to get older. Have you ever heard about that these days? That aging is not a disease. So in an AI view, disease is whatever, for them, is like label a data set. So AI doesn't know what is aging or what are some topics about the human being. For the AI view, is like, I will say this, like garbage in, garbage out, or data in, data out. But he discovered some patterns. So if the training data reflects biases, the ontology of disease is flawed. But this is because human being is explaining this with ontology. So who decides what is a disease and what is not? Because in some parts of the world, something is a disease, in another parts, it's not a disease. Let's explain, for example, with homosexuality. It is the same. For one time, it was a disease, but right now, it's not a disease. So how are you going to train your artificial intelligence model if you are going to say the model, this is a disease, and this is not a disease? But it was because a human put that label on the model. So we can, this is a philosophy that we won't end, no? But one point that we could stress is that AI doesn't know what at some meanings like disease, just know about labels. And doctors, for example, they even anchors them to life from stop human suffering. So what kind of strengths and blind spots in general we can talk about in the doctor context? As we said before, contextualization, or for example, a very holistic view. For example, is doctors just doesn't know just about medical issues, but they need to know about other things. For example, like law, other branches, other topics. So they have an holistic view, an holistic judgment. Also, some doctors have a lot of empathy with the patients, and they are ethical reasoning. This is something that AI doesn't have ethical reasoning. Some of the weaknesses are, of course, subjectivity. Why? For example, we explained before that the way the patient is describing something is very subjective, and the doctor needs to guess, needs to use another methodology in order to get the right point where the patient is. Also, another weakness is that is limited memory, and they, of course, as a human being, falls in the fatigue. And what about the algorithms' strengths? Well, we can scale it, as we have seen, and they have some kind of consistency if we are training the model like that, and the ability to detect like non-obvious patterns. And what are another weaknesses? The lack of causal reasoning, vulnerability or biases or incomplete data sets. But of course, this is a huge word where biases could be determined for the type of data, but also for the person that is training the model, the person that is coding the model. In this case, this is the Berkeley experiment where they realized they had images with the color of the skin. So when they pass a biometric, they didn't realize the other person at the right or at the left with a different color skin, they don't pass the biometrics, because in that regions just got some type of skin. So as Dr. Tim said before, the robustness of your data samples, you need to realize what type of data are you in your data, have you in your data sets, like an input. So I am going to mention 2 cases, but there are a lot, that tend to divide opinions, because some of the professionals are against artificial intelligence because are afraid about what is going to happen, and others are for artificial intelligence. So for example, in the case of the radiology, AI often outperforms radiologists in images detection tasks, but a radiologist doesn't just detect the lesion. They contextualize findings in patterns history and more. Another, for example, the psychiatrists are also concerned about artificial intelligence because doctors integrate subjective narratives and cultural concepts and behaviors, while AI tools may flag, for example, depression from speech patterns, but they lack understanding of cultural nuances. So imagine that you are using the speech pattern recognition of your cell phone, and one day it's going to tell you, I know that today you are sad, and could be quicker than your family, than your friend, than your doctor. So we have the technology using that, but who is taking care of the technology? Who is giving the credit of each algorithm? That's why I would like to share with you a very important thing, that is literacy on AI models. I know that we feel the pressure that you must, it's a must, you must study artificial intelligence, or you must to use artificial intelligence. So you must to do it, but we need to establish how are we going to use it in a better way. So we want to establish that AI literacy, it doesn't mean that you need coding skills. So it's about, for physicians in this case, and other professionals, it's about interpretation. It's about limits. It's about critical issues. So for example, doctor must understand what kind of data trains the model. Imagine that a computer scientist or an engineer without the formation of a physician is doing this work with the data without the supervision of a doctor. So we need the supervision of a doctor in terms to understand what does it mean, a trained data, or what does it mean, the model. Then, of course, we have a lot of types of measurements, like we can measure risk, probability, labels, in different tasks. Where are the blinded spots? Well, we have detected some of them, but there are a lot, like biases or generalization or explainability. So for this slide, we would like to emphasize that all of us need to have more of a literacy on AI models in order to a better use. It is the same case with the use of ChatGPT. We need to understand how to use it in a better way. Okay, so let's say an example from a clinical analogy. Doctors don't build microscopes. It's not their work, but they know how to interpret what they see through them. They must learn to see through AI models. It is the same. Physicians are not going to code, but just they need to understand what are they doing in order to help their patients. So the goal is to empower doctors and other professionals not to be passive but with AI, but to have a better use of it. So this is why a very new field for us in Mexico, in Latin America. I haven't realized if in other parts of the world, but they are emerging fields like AI governance. Before AI governance is data governance. So what does it mean to govern a data, to govern a model? Is to have transparency that what is the model doing? We don't like, we don't need a black box. So, and who wants the right to know? What is the transparency? In accountability, who is responsible in AI misdiagnose? For example, there are a lot of parties involved in the development of coding, in the use of the coding. So in accountability, who is responsible? The doctor, the developer, or the hospital? So you need to be careful with the documents that you sign, no? We also, for AI governance, would like to have equity to prevent biases, example, racial, gender, socioeconomic, and from being embedded in healthcare AI. We also need to know more about the regulations and standards and to know that they are not forever established. They are also changing every day, like the European Union AI Act or like the FDA frameworks and the ISO standards in health informatics. But if you like these kind of topics, you also can participate in say what is missing about physicians with artificial intelligence. And of course, another important topic is the trust. Patients must feel like AI supports care, not replaces caregivers. So, and there are some places around the world where they are using artificial intelligence in hospitals right now, like with the patients. So we want to develop in that way, but we need to be careful and to be prepared. I am going to share with you, this is the data governance DAMA DM-book framework that you can find on the internet, but this is one of the most important frameworks, at least here in Latin America. Of course, there are others, where people is trying to say, what do we need in order to govern data and artificial intelligence? So for example, we need a data architecture management. But I am going to talk you about this, for example, the architecture. Do you know the racks and the servers, like the AWS or Google Cloud? Well, they have the data, but what happens if that kind of enterprise suddenly decides to keep with the data because it's in the cloud? Or, for example, a Mexican hospital, why does United States could have Mexican data from healthcare? So did you give your permissions for your data go to the United States? No, we are just, is a theory, but if you want to find what is happening, because when you use the applications, it is very common that you just click OK, but you don't read the terms. And you don't know who has your data. And that's why it's happening. So the architecture, yes, means also where are they located? Where are located our data? The data development, okay. For example, when we have some data, we can manage them and calculate new values in order to develop another new data, for example, in deep fake artificial intelligence algorithms. That is not for a good reason. Another one is the database operation management. And the database is when we used to have structured data. And those are very, if you are very familiar with that, like how to use SQL, they are some of the data that are well structured. But of course, we have another type of data that is not structured. What about the data security management? So when we go to hospital, the hospital has our data, but do we know what the hospital is doing with the data? Do we really read about it? And of course, topics about hacking the data. The reference master data management, well, this is another topic about master data that are the most important data in your model. And the reference is another international standard where you can manage your data with the master data. The data warehousing and business intelligence management. Data warehousing are also to make with the business intelligence, to make that beautiful dashboards in order to give us a very fast information. But they, as it says here, when they say business intelligence, is because they use it in purpose to sell our data or to know what are you doing and to get your attention. The document and content management. This is extremely important. We are in Latin America, not used to document the things that we are coding. So if another person wants to read what this model does, you don't understand because nobody wrote what it's about. So we have bad practices about this because it's preferable to document all the things that you are doing. And of course, who is coding? So the name of your team, the name of your boss, and the metadata management are another type of data that for some users are hide. Are type of data that you cannot see. For example, when you take a photo, it also stores the date or the GPS, but you cannot see them maybe. But in terms of some engineering, you of course can work with that. if you know how to do it. And to finish with the wire, the data quality management. This is the very important that the quality of the data, that is like the main goal with the security data. They both. So all the circle works for the quality, the security, and at the center, all of this is to govern the data. So it is, as you said, as I said, it is very difficult. Data, 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 data. There are a lot of types of data. And everything is management, management, management. What I am going to manage is very difficult. So we need to govern the data and govern the algorithms. Because if we doesn't do that, we are going to lose the things that we are going to improve. Or somebody else could steal that because we are not aware about this type. Well, let me tell you something. This weir doesn't have artificial intelligence. It's missing. Doesn't have, for example, artificial intelligence, I am going to leave you like that. So if you are curious about that, read the Dama DM book, and then we can construct the AI governance. So towards hybrid intelligence, not just the doctors is stronger or the algorithms are stronger, we need to blend them. We need to bring them all together, and doctors with the contextual, with the humanity, with the ethical, with the narrative driven, plus the algorithms that are scalable, consistent, data driven, with AI literacy, equipping clinicians and physicians to critically engage with models, not surrounded to them. So with this, AI governance ensures that systems are safe, fair, and accountable. But this, we have a lot of work to do. So not doctors versus algorithms. We would like you to invite to stop having fear about these topics when you go deeper, because there is a lot of people that can help you to understand and to use it in a very, very well manner. So instead of doctors versus algorithms, why not doctors plus algorithms under government with literacy as the bridge? So thank you very much.
Thank you so much, Professor Jessica Huelgas. Is there a question from the public that, okay.
Okay, first of all, thanks for the presentation, for this magnificent session. And it's not just a question, it's about a comment. Well, I'm Axel, I'm a physician scientist, and I agree with most of the things you are telling us, but I just think that the more reality for doctors, especially in Mexico, it's there. For us, it's a little bit difficult to understand how AI models works. I'm a doctor who learned to code, and I'm working with AI models, especially for single cell genomics. And the reality is, when you work with these deep learning models, you don't really understand how they works. And I just think most of the engineers, they don't understand also. And the reality is, that most of the times engineers are trying to create solutions that we will not eventually use it because they don't understanding, they are not understanding the clinical context. And doctors, we have the same things. Now we are understanding how the AI models works. But the reality is, at least in the School of Medicine here in UNAM, we as medical students, we are learning how to use AI from the basics. We are not mathematicians, but we are learning from Bayesian theories, and we are learning how to how's the inside of the AI models. And I just think the future of the AI, it's not about clinical decisions. It's about how to improve workflows. Because most of the time, when you are a doctor, you spend a lot of time with this proof communication. So if the AI strategy is focused more on workflows than clinical decisions, that would be super useful. I just think that the next generation, or the next future of medicine would be specific chatbots like ChatGPT for the hospitals without using critical data. That will be probably the best idea. Thank you.
Thank you very much for your opinion. That's why we invite to join us, because we, at least at UNAM, I can just opinate it for my institution. Most of the time we are very separated. We don't know what you do, and you don't know what we do. And it's with every faculty, something similar. So this is the place, and this is why we form this hybrid school, in order to invite you to join us and to start the conversation. It is because it's not done. It is new. There are a lot of challenges. So thank you very much for your opinion, because it's the same that you are telling about. Sometimes you don't understand nothing because it is difficult. As for me, is to study medicine. Imagine, it's very difficult. So I am not going to study medicine, and you are not going to study engineer. So what are going to do? We need to establish a path. And what about the experience of the German school and their experience, where they already have done with the government, with the physician school, and with the scientist school. So I think we have a lot to learn, and we go further. Thank you.
Thank you so much for your answer. We have a question from the YouTube. What would you tell the doctors to stop being afraid of AI usage going wrong? And how can AI governance can limit the use of AI without disrupting creativity in the medical field?
Oh, could you repeat me the second part, please? The first one is about the fear, and the second one?
How can AI governance limit the use of AI without disrupting creativity in the medical field?
Okay, well, for the first question, well, about the fear is a very human feeling. So maybe I can, of course, I can speak about myself. When I started to coding, it was very difficult at the beginning. It's not easy, but as everything has a process. And as a friend of mine told us, if you would like to learn how to swim, you need to get into the pool. So, and the other question?
How can AI governance limit the use of AI without disrupting creativity in the medical field?
Okay, limited. Well, it's establish politics and establish roles. But in that way is that we put limits. And it is good to put limits because we need to be secure with the data, and we need to have a quality data.
Thank you so much for your answers. Is there another comment or question from the public in here? If not, okay.
I think, well, thanks for you talking. My question and comment is, well, it's the first time that I'm listening data governance, and I think it's really important. Will be really helpful to like to gain confidence and trust in our algorithms, right, with people. So, is there anything else we can do to, well, make faster this change into like traditional medicine to use AI, machine learning tools to help people?
Yes, of course. That's why we are inviting a lot of people, and of course, young people, because we need a lot of creativity. So if we have some other types to focus or to address the problem, we need to try it, and then we need to test if it's okay to go in that way. But the first thing should be that that scientists like mathematics, physics, computer scientists, engineers, go with physicians and say, what do you need? What do you need for me to do with you, by your side? And explain each other that differences, because we don't speak the same language, but we can make it to work. So if young people has new ideas, bring it. Thank you.
Thanks.
Yeah, the part of the fear that you're talking about, kind of reminds me the first uh, industrial revolution, where people attack machines because they were afraid to take their jobs up. And well, it kind of reminds me this situation because most of people are afraid of this AI can take our jobs. But it's kind of a new opportunity because the industrial revolution brought new jobs. So that is my question. Like, what kind of new jobs can be born about AI? And because in a country like this, in Mexico, is a university is not an opportunity for everyone, and coding
Yes.
and programming and AI is necessary, maybe a university career. So that's my question. What will it be a new job that could be more general to most of the people that could be born of AI?
Well, I will suggest to review these type of topics of uh, how many types of data we have, because I am certain that this is very far from us, this type of knowledge. And it is true that, as you said, in the university, we have a lot of opportunities that other person doesn't has when they cannot afford for a university. So um, we can establish, like, this will be the base, the foundations, the data governance, and the next step could be governance, the AI. But you have here two branches. One branch is you would like to develop the tool, so you need to code. If you want to develop the tool, you need to code. But if you want just to understand, you need literacy. Thank you.
There are no further questions, so can we give an applause to Professor Jessica Huelgas Moreno, please?
Thank you.